I'm doing this video sort of as a follow-up to my lint filter water alarm, my super cheap water alarm circuit. I didn't really get into the nuts and bolts of how the Darlington circuit works in that video. I kind of assume you know transistors and Darlingtons. If you're really basic on transistors, you need some real basic knowledge on transistors, go back to my video under Arduino, using Arduino electronics for Arduinos or something like that. It's in my Arduino series, basic electronics for MCUs, something to that effect. And there I explain transistors more in depth. I'll go through real briefly though. Here's your basic transistor circuit. Say this is a push button here, and this is a resistor. Now the base emitter junction, this is the base, this is the emitter. The base emitter junction is going to be like a diode. I'll get a better pointer here. It's like a diode. It's drawn like a diode kind of, and it is a diode. It'll drop 0.6 volts just like a diode would drop 0.6 volts. That's why I drew this here. So if I chose a resistor at a given voltage, I chose my resistor to give me, say, 1 milliamp, and the transistor had a rating of a beta of 50, then I could control a 50 milliamp load, up to 50 milliamp load. And you could look at the specs of the transistor for the maximum base current, and my output current could be 50 times that maximum base current, providing it didn't exceed the maximum current rating of the transistor. So that's the basics of a NPN transistor. This is an NPN transistor with the arrow pointing away rather than pointing in. Small current goes here, bigger current flushes through here. This is called an open collector circuit. A lot of times a device will give you open collectors at a terminal in the back of the device so you can hook up something else to control. So you can sync current into the open collector. And again, refer to my Arduino, basic electronics for Arduino video, and I'll get into more of the discussion over this. So that's the review for that. Now let's say I wanted to use something other than a touch switch here. I wanted to use, rather than a push button here, I wanted to use a real crummy switch. In this case, something I could just touch. So my skin's got a high resistance, maybe 1 megohm, let's say, just for, you know, if this was an actual metal, the black lines were actually metal, my finger might present like a 1 megohm load here. Let's just use that for an example. That would be not enough current to flush through. If this was a touch switch here, and I touched it, I wouldn't have enough current to fully turn this transistor on. If I had enough current to turn it on at all. Well, it would probably, depending on the voltage and all. I would only partially turn on this transistor, and my load would only be partly turned on in proportion, 50 times more current than the little tiny bit of current going through my fingertip. So there's something called a Darlington, named after somebody with that name, where you can put two amplifying devices together more or less in series. My base emitter junctions are in series with each other. So it's like having two diodes in series. I'm going to need more than 1.2 volts to get this thing working at all. But instead of having a beta of 50, let's say I'm using the exact same transistors in this circuit as I'm using in this circuit, which is pretty close to what the 2N222s that I was using in the other one. Actually, that's probably a PN222. The original 2N222s came in a metal case. So if you buy them in a more traditional plastic case now, it would say PN2222, or it would be 2N222 with a letter after it. because the original 2N222 came like a, missed a 2 there, came in like a TO18 case or something like that, a little metal case. At any rate, these are some other examples. With the kits you'll find with the Arduino or other circuits, you'll real commonly see this 2N3904. If you needed a big transistor that was really common for a heavy load, you could use a 2N3055 or MJ3055 or anything in that family. Give you almost a 20 amp capacity of switching, you know, a 20 amp load. At any rate, when I put these two transistors together in series, so to speak, my beta is now squared. So I now have a super sensitive circuit. And that's how I'm able to switch my load. I had load written here before. With just my fingertip. And this is what I did in my washing machine filter, and this is how you'd hook it up. So I wanted to clarify that because I kind of went over it real briefly in the video for the washing machine lint filter alarm. You can also buy a Darlington where the two transistors are in one case. Kind of poorly drawn here. That's why I put the circle around both transistors, symbolizing you can actually buy a Darlington transistor. It looks just like a regular transistor. Same kind of packaging a regular transistor would be in, but it'll have all these characteristics that this will have here. The 1.2 volts between the base and the emitter, and the super high gain. Okay, now if I want to do the same circuit with PNP transistors, if I happen to have a bunch of 3906 transistors around instead of 3904s, well, I could do the exact same circuit, more or less. Put my two transistors in series, tie the collectors together. This time, though, my other side of my probe, other side of my touch switch, is going to go to ground rather than hot. These are both my ground or my 0 volt connection. You know, as over here, they both went to the positive connection. So, hope that helps a little bit for anybody who's real basic on what a Darlington is about. Basically, it's two transistors together, and your beta is squared. And the only downside to it is you have a 1.2 volt instead of a 0.6 volt to satisfy before it'll start conducting. The other downside to it in power applications is thermal runaway, but that's beyond the scope of what I want to talk about here.